Greetings, Algebra 2 students. This is Dr. Heron talking to you about Unit Notes 5.4, talking about multiplying probabilities and trying to figure out kind of what the probabilities are of combining situations, of compound situations. So what happens when I have one situation and then I multiply it times another situation. So you have compound events, which are basically just combined events. All right, and this is kind of the important part. You're basically going to say, what's the probability of the first thing happening times the probability of the second thing happening? And if they're independent, they got no effect on each other, it makes a little bit more sense. Sometimes when it's dependent, you have to be very, very careful about what you're looking at. So, at a picnic, Julio reaches into an ice-filled cooler containing 8 regular soft drinks, 5 diet soft drinks, removes the can, decides they're not thirsty, and puts it back. What's the probability that Julio and the next person reach into the cooler and both get a regular soft drink? So the probability of Julio getting a regular soft drink is going to be 8 out of 13. 8 regular soft drinks, 5 Diet Cokes, or 5 diet soft drinks has 13 drinks. So then he puts it back, meaning he doesn't drink it, doesn't pop it open, whatever. Puts it back. So the second person also gets a regular drink. So that's going to be 8 out of 13 times 8 out of 13. Okay, so 8 times 8 is 64. 13 times 13 is 169. So the probability of that happening is going to be 0.379 or 37.9%. Okay, or as a fraction, I would leave it as that. Okay, so you're going to figure out what are the two probabilities, multiply them together, and see what you get. Okay, so in a state lottery game, each of the 3 cages contains 10 balls. All right, whatever I draw on the first one has no impact on the second or third one, so it's going to be independent. So you have to each get 3 digits in a row. What's the probability that the first 2 balls drawn will be even and that the third ball will be prime? All right, so the first 2 balls are even. So you have 2, 4, 6, and 8. Okay, 0 is not even, so we do not include 0. So that's going to be 4 out of 10. Then 4 out of 10 for the second one. And the third one will be prime. Prime is 2, 3, 5, not 6, and 7, not 8, not 9. So times 4 out of 10 again, okay? So that's going to be 2/5 times 2/5 times 2/5. Okay, so you're going to multiply the top, so you get 8 out of 125. So that's your probability. That's going to be the chances that you get that, or 6.4%. Okay, that's what happens when I divide those two. So compound events, independent, dependent, we've talked a little bit about this before. So one does not impact the other, one does impact the other. So you got to kind of look at what we're dealing with. So is it dependent or is it independent? So if this is rolling a dice and tossing a coin, that's going to be independent. All right. Selecting a red apple and then a green apple from a bag of 6 red and 4 green apples. If no apples are returned, so without replacement, okay, so that's 6 red apples, 4 green apples. No apples are returned. So you pull out a red apple, you keep it out, then you pull out a green apple. That's going to be dependent. That's going to be dependent. And the last one is selecting a red apple and then a green apple from a bag of 6 red and 4 green. If the apple is returned, so that's with replacement. So that's going to be independent. So now, probably dependent events kind of looks like this. So you take the probability of the first thing happening, and then what's the probability of the second thing happening after A has already happened? Okay, so what's my probability left, basically? So drawing 3 cards of the same suit without replacement. Okay, so 3 cards, same suit without replacement. So I draw them and I keep them. Okay, so now, first one, I can draw whatever card I want, all right? So that's going to be just 52 out of 52, all right? But once I do that, I'm locked in. I've got to have either the same suit, either the heart, the diamond, the club, or the spade, all right? And there's going to be 12 of those left, all right? So it's going to be 12 out of 51 and then 11 out of 50, okay? So another way to think about it was, yeah, I'm going to take 13 out of 52, 12 out of 51, and 11 out of 50. But I can do that for 4 different suits, so I can multiply it by 4. These two things are the same, because 4 times 13 would just be 52. So it's kind of the same thing. So what I'm going to do is say, 12 over 51 times 11 over 50 is going to be 0.0517, so 5.17%. So about a little over 5% of the time is going to be 3 cards of the same suit, so not very often. Okay, so we start looking at some of these examples, finding the probability. 3 cards are drawn from a standard deck of cards without replacement, so it's going to be dependent. Find the probability of drawing a heart, and a spade in that order. So your probability are heart, spade in that order. So you got 13 hearts out of 52. You got 12 left out of 51 cards. And you got 13 out of 50. So the probability of doing that is going to be let's see, 13 out of 850, or 0.0153. Okay, so a spinner is number 1 to 7 and toss a coin. So this is going to be independent because the spinner and the coin don't care what the other one does. So what's the probability of getting an odd number on the spinner and an even and a tail on the coin? So odd numbers 1, 3, 5, and 7, and a tail on the coin. So 1 to 7, so you're going to have 4 out of 7 times 1/2. So that's going to be 2 7, so that's going to be 0.286. So keep going, same ideas. You reach into a hand with a bag of Scrabble tiles. The bag has 1 tile with each letter. You pull out the first tile, then another. So it's going to be dependent because you keep the first one. What's your probability that you get a vowel, then a consonant? So the vowels are A, E, I, O, U. You're not trying to include anything else. Then you've got 21 non-vowels out of 25 25 letters left. So that becomes 21 over 130, or 0.162. So a card is chosen at random from standard deck of 52 cards without replacing it. So without replacement tells you that it's going to be dependent. What is the probability that the first card chosen is a queen and the second card chosen is a jack? So you've got probability of a queen, then a jack. So its probability of a queen is 4 out of 52. Then you have 4 jacks left out of 51 cards. All right. So you're going to get 0.006. So a very, very small number. 4 out of 663 simplified. And the last example, 4 hearts in a row, but you are putting them back. Okay, so this is with replacement, so it's going to be independent. So you're going to take 13 out of 52 times 13 out of 52. You're going to do that 4 times. All right, so you're basically going to take, it's 13 out of 52 is 1/4 raised to the 4th. So you're going to get 1 out of 256. which is going to be 0.004. So a very, very small likelihood that you're going to get 4 hearts in a row, even putting the card back. Okay, so let your calculator do a lot of the multiplying for you, and then make sure that your setup is going to be the correct one.